Hello everyone, welcome to AI with Raj. Today we are here with an interesting topic which is NLP evolution. As on a daily basis you interact with ChatGPT, Gemini models, Copilot, have you ever realized where it has all begun? So let me explain you the NLP evolution today. First of all, let's understand what is NLP. NLP is nothing but natural language processing. So what is NLP? On a daily basis, you either interact with Alexa or Siri, right? You will just ask, like in any language, play latest song from Pushpa movie. So now what happens is that your speech will be converted to the text and then it will detect what is the language in which you are speaking, and then that particular request will be processed internally and then it retrieves the information, your request will be processed. So here what happens is, as I say that play a latest song from Pushpa movie, now my speech will be converted to text. The text will be processed in the Alexa internal system and then it retrieves the latest song from the Pushpa movie and then you can enjoy that song. In this way, NLP can help you to bridges the gap between the different systems you interact with or bridges the gap between the human and the computer. So now let us see how this all began. So 1954, the researchers have first released a bag of word model. So bag of word model, what it will do is, in your document, how many words are present. So basically what it will do is, it will try to find the number of tokens which are present in that document. And then based on the number of tokens, you will be able to do the spam detection, text classification, sentiment analysis, etc. So what happens with bag of words model is that, so let us take an example. Suppose in your mailbox, you must have received an email saying that, congratulations, you have won a lottery. Versus you will be having another email, congratulations on your first car purchase. So here what happens is, your mailbox says that the first email, which is, congratulations, you have won a lottery, with a probability that it could be a spam with a probability of 95%. Versus the other email, congratulations, this is your first car, your mailbox will not say that this is a spam. How this process is happening? Because over the years of training, the bag of words model must have picked few tokens that this is congratulations, won a lottery. These are the probable keywords where this particular email could be higher chances of a spam versus the other email. So now what are the limitations of this bag of words model is that it will not be able to understand the word context, or it will not be able to understand what is the semantics which are present in the word. It will also not be able to understand the word order in which the tokens are present in the document. So now next evolution happened, and then TF-IDF model, which is present in the picture. So TF-IDF is nothing but the term frequency and inverse document frequency. So term frequency is, in a word, how many times a token has occurred, that is a term frequency. So inverse document frequency is, suppose in a document, the particular word or a token might not be a probable high occurrence, but it is having the very probable high weightage of, though it is a rare word, it could be having the higher weightage corresponding to the semantics of that particular document. So in this way, TF-IDF combine together and then assign a weightage to that particular word in the document. So with TF-IDF also, what we can do is, we can do the spam detection, we can do the text classification, sentiment analysis, etc. Now what is the drawback of TF-IDF? TF-IDF also, the drawback is that it will not be able to understand the entire semantics of that particular document, because it doesn't know what is the semantics, and then it will also not give any weightage in which the occurrence of the words are present in the system. So hence then the evolution happened with the word to vector. So word to vector model, which has got a breakthrough, like it will be able to understand the semantics of the words which are present in the document. So how it understood the semantics of the word is because over the years a huge amount of training has happened to the word to vec. So it will convert the every word into a vectorized format. So let us take an example. If you take cat versus dog, so cat will be converted to the vectorized and then dog will be converted to the vectorized format. These two, we will find a similarity. Then as over the years of training, it understood that these two are the probable category of animal. Hence, these two similarity score will be higher compared to if you take any other example like cat versus apple. So for these two, the similarity will not be high because these two does not belong to the same category, right? As cat belongs to the animal category and apple belongs to the fruit category. So like this, huge amount of documents have been trained for this word to vector, and then we could able to get what is the similarity score between the different words. Hence, we will be able to understand whether these two are semantically similar or semantically not similar. So let us take an example. Congratulations, you have won a lottery. So in this, it will try to understand the semantics like, okay, how this lottery and won, these two might be mostly occurred together in most of the mailboxes. Hence, we will say that with a high probability, this is a spam. Versus congratulations on your first car purchase. This could be very less occurred email in your mailbox. Hence, these two could not be gelled together. Hence, it says that it could not be probably a spam. So like this, word to vector has laid a foundation for the breakthrough which is happening as of today with the different models like GPT, BERT, etc. But still, word to vector has a problem, which is like, though it understands the semantics, it does not give a weightage to the word occurrence, in which order the words are coming in the document. And then the next breakthrough happened, which is RNN. RNN is nothing but the recurrent neural network, which is one of the most used neural networks in the NLP, natural language processing. So RNN, how it will work is, it will process your documents in a sequential format. In sequential format, what happens is, let us take an example. You are drafting an email. You must have multiple times observed that as you start typing the email, the auto completion comes. What could be the probable next word? So how it is helping you is, it will tell you what is the highest probable similar word could come after you type your current word. So in this way, RNN can help you in your sequential process. But RNN has a very huge problem, which is vanishing gradient problem. If you process long sequences, what happens is, as you process a long sequence, there is a high probability that it must have forgot what is already processed in your sequence. The first processed word, second processed word, it must have forgot. And then currently, as you process this particular word, it will not remember the previous words. So hence, because of this vanishing gradient, it might not be applicable as you work on a very huge lengthy documents. Hence, LSTM is into the picture. LSTM is nothing but long short-term memory cells. So LSTM is majorly published to mitigate this vanishing gradient problem. LSTM will be having multiple gates. So it knows which to remember, which to forget, and which to output. Because of these different gates which are present in the LSTM, we will no longer, this vanishing gradient problem is valid. But the problem is, if you process the lengthier documents in a sequence, in real world, it is very computationally intensive and it is very time consuming process. If you put this on a real world applications, you might expect a latency in the responses. Hence, in 2017, the researchers have released a transformer model with a paper published, which is attention is all you need. With the self-attention mechanism of this transformer and the parallel processing ability, which is going to solve you many real-world problems which we were facing at that point of time. So here, how this transformer model will work is, your entire document will be processed at once, and then it knows what are the different entities which are present in that document, and then for which entities it has to put more attention. So because of this, it will be able to remember the entire context by not forgetting any of the context. So this laid a big foundation for the recent models like the Google BERT model, also the GPT models. In 2020 itself, OpenAI has launched the GPT models, the GPT-1 and GPT-2. The problem is, though they are kind of generating the content or generating the images, those are not near to the real time. Because of the less amount of the data they have been trained, it is not able to give you the real world output. So now in 2022, as we all know that a big breakthrough has happened in this AI industry, where the launch of this GPT-3 model. So here what happened is, in GPT-3 model has been trained on billions of parameters. It is able to generate near real world the content, near real world images. So with this GPT-3 model, we all on a daily basis interacted with the chat GPT. As you ask a question, it is able to generate the text for you. It is also able to generate the images for you. And today, like the DALL-E model is generating the images. And we are also seeing, as you pass a text, you are seeing the videos are being produced. So now in these days, the multimodality models are also present. The LLMs, what they are doing is, one single model can be able to function the different things, like the same model can generate the image, the same model can generate the video, the same model can generate the text as well. Generative AI has come a long way from its humble beginnings to the advanced models we see as of today. We are living in an inspiring times where technology can create, innovate, and even inspire. If you like the NLP Evolution video, please do follow us. Till next time, keep learning and stay curious. Thank you.